Okay, let's go over how to get this problem on the calculator. Your calculator has a built-in inverse normal distribution key. In other words, the inverse distribution will take a probability or an area under the curve that's normally distributed and then translate that back into either a z-score or an x value. Okay, so what we're going to do for part A is, remember, the problem states what height represents the 90th percentile. So the area under the curve, under the normal curve, is 0.9. So I'm going to use my distribution menu. Okay, the same menu where you find your normal distribution. Okay, so you notice that choice 3 is inverse normal. You could either arrow down to 3 or you can press number 3 on your calculator. Okay, so the general format for the inverse normal is you're going to put the probability in first, comma, mu, comma, sigma. And again, the calculator defaults to the standard normal case. So if we want to go directly to the x value, we're going to put in the probability or the area, which for this case is 0.9, okay, comma, and then the mean was 69.6, and the standard deviation was 3, and close parentheses. And that's going to return that height or that x value. And we found that it was approximately 73.44 inches when we found that z-score using the table. Now, to use the inverse normal to get a z value, you go back to the distribution menu, and this time I'm going to just put in 0.9, oops, and close parentheses because it defaults to standard normal. So if you notice that 1.28155 and so on is approximately the same z-score we got with using the table. The closest I could get using the table was 1.28. So that gives you an alternative way to find a z-score if you find that the table is limited. I do want to mention though that a lot of times the software and the textbook will use a z-value or a probability from that table. The one you get from the calculator or StatCrunch or Minitab will be a little bit more accurate, so you might end up with some rounding differences. Okay, so let's go ahead and answer part B. Part B was what height represents the first quartile. Now remember that the first quartile represents 0.25 area under the curve in that lower tail. So again, I'm going to go to my inverse normal function here, and I'm going to put in the area first, which was 0.25, okay, comma, and I want to go directly to that x value, so I'm going to put in mu and sigma. I could get that z-score and then calculate that x value by hand like we did previously, but this is much nicer and a little bit more quick. Okay, now close parentheses. Okay, so you'll notice that we get 65.57653 and so on, which is approximately what we got when we did this by hand.